Okay, so good evening guys, good morning. Ano nga oras? Ayun nga da. So again, this video is makatrayod kita video karang piso. Di kita darom. May at least option natin na himon pandemic. So busy ra sir, himon ang video. Okay, we have a problem here. Calculate the heats of combustion for the following reactions from the standard enthalpies of formation listed in Appendix 3. So, I guess sa iyo Appendix ibada. But anyway, may gamay ito nga diferensya kung iba-iba nga table. Pero, kabaraka. Ang pinaka-main niya usually, meaning first two significant figures, which is usually aton multiple choice kung examine. Direct yan na bago. Now we have two cases, combustion of C2H4, I think that is ethane, and then letter B is combustion of H2S. So we will write each down actually for I'll use the blue for ethane. For ethane, the combustion, heat of formation standard for ethane, CH4. I'll write it like that. I'll go to a table. Where's my table? That is C2H4. Ade. So C2H4, be sure kung danay may gas kasi ito. So this is 5226. Formation of ethane is an endothermic one. That is 5226. 5226. Yes, that's it. 5226. 52.26. So, I'll post ka ng piso para sa oras. Okay, I've already listed the constant here on my screen. So, anyway, you can expect that the summation of this for letter A, because it's a combustion, it would be a negative value. Even though your formation of ethane is an endothermic reaction. Okay? So what we do is, of course, we use the His law of summation. That is the delta. Sometimes you can call it the standard heat of combustion. You can say heat of reaction, probably reaction here, or combustion. We can say reaction for general purpose. That is your ethane reaction should be product. So maybe we have to include a parenthesis for all your products. So our product is carbon dioxide. So you have 393.5 kilojoules per mole. And then we can see from the chemical reaction that we have how many carbon dioxide? There are 2. So we multiply it by 2 moles. Okay. And then for another product is water. You can see that it is liquid because there are 2 listings of water usually in the table, the liquid and the gas, because they have different heats of formation. So you have water molecule plus, that is the negative. So we have plus because again the equation is summation of heats delta, heats of formation of these particular compounds at standard states. Okay, so you have positive plus, your water is negative 285.8 kilojoule per mole, and then so that is all, and then multiplied by 2 also, 2 moles, kilojoules per moles. So that would be it, minus the reactants. So your reactant is C2H4 first. So you have a 52.26 kilojoule per mole of your C2H4. Your C2H4, you have only 1 mole, so need not. Then plus oxygen. Use oxygen has 0. Usually for elements, metals, elements, and because your oxygen is an elemental form, O2, so usually they are 0. Okay? So, all in all, we can use a calculator. So that is negative 393.5 times 2 plus negative 285.8 times 2 also minus 52.26 times 1. So all in all, we have negative 1410.86. That is kilojoule. Okay, as I've said, we can expect a negative heats of reaction for this one. That is negative 1410.86 kilojoules for the combustion of your ethane. Of course, from table of their formation. Again, combustion is the chemical reaction. Danay, tawag ito nga heats of combustion. Pero generally, you can call them the heats of enthalpy of reaction. From their formation. Formation liwat is paano hira ginhimo nga iba-iba nga pamaagi usually. I think kasi may iba-iba nga pamaagi pag sukol na era. So, just like this one, we just calculated the heats of reaction, but actually, you can put in a calorimeter and then you can really find that one for 10.86. So, depende na ito on accuracy. Of course, this is from accurate formations. As you can see, kung ibang table yung gagamitin, medyo pa may pagkakaiba. Because damo talaga mga scientists and nag-derive din yung mga tables. Okay, thank you guys. May da pa usa. Sorry. For H2S, I'm sorry, may da pa yan. H2S, the combustion of your hydrogen sulfide, H2S. This one. So, may I first look at the table. So, may I pause. So, I have already listed the values for this one. So, for your here's here for hydrogen sulfide H2S, and here's here for your SO2. So, delta heats or enthalpy of combustion or reaction, the combustion reaction na general. So, that would be the product from the His law. Summation of the product, your product is SO2 and water. Your water, again, you have to look for the water which is liquid. That is 285.8 kilojoules per mole, and then you have two molecules of water or 2 atoms. Sorry. Control, that is 2 moles, and then plus your SO2. You also have 2 moles for your SO2, that is negative 20.6 kilojoule per mole times 2. So these are your products minus your reactants. Your reactants is also 2 moles of H2S. Oh, I think I was wrong. SO2 is 296.8. For your reactants, you have H2S, you have minus negative 20.6 kilojoule per mole of your H2S, so that is multiplied by 2 moles. And then lastly, for your oxygen, this one actually has 0. Anything molecular or elemental has zero heat subformation. Even metals. Metals, ano pa. Anyway, may na. And then we get a calculator and we sum these things up. So, parenthesis, negative 285.8 times 2 plus negative 296.8 times 2 also. So, minus negative 20.6 times 2. So, you get negative 1124. Negative 1124. Of course, the kilojoules would be, the moles would be cancelled from those equations. So, we have kilojoules. So, energy talaga, verbatim. So, this is the energy you can get out from burning hydrogen sulfide. So again, this is an exothermic reaction. So you can expect that for combustion processes. Okay? Thank you guys.